So today we're going to learn about radian measure. And angles can also be measured in a unit called radians. Typically we measure angles in degrees, but radians, you have to kind of think about it this way. Just like 0.5 is the same thing as 1/2, it's the same value just written in two different forms. That's how radian degrees are kind of related as well. Okay, it says to define a radian, consider a circle with radius r centered at the origin. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of r. And so basically 1 radian has a measure, and this is not something you'll have to calculate over and over, just to kind of as an explaining. When your radius and your outside arc are the same length, that means that that angle has a measure of 1 radian. Okay? And since it says since the circumference of a circle is 2 pi r, there are 2 pi radians in a full circle. All right? So normally a full circle we think of as 360 degrees. That is the same as, 2 pi radians. Those are the same measure, just different units. And so what we're going to look at today is how you can change between degrees and radians, because for some problems you do have to use radians and for other problems you need to use degrees. Okay? If you want to change a degree measure to a radian measure, you are going to multiply your degree measure by pi over 180. If you want to change a radian measure back to degrees, you multiply by the reciprocal. You're going to multiply your radian measure by 180 over pi. And that will cause the unit you don't want to cancel out and the one you do want to remain. So let's look at a couple examples. This one says convert the degree measure to radians or the radian measure to degrees. Well, this one is starting me with 120 degrees. So I want to change this to radians. So I am going to multiply by pi over 180 degrees. Well, my units that I don't want cancel out, and I will just, if you need to, think about this as over 1, multiply straight across, and you will end up with 120 pi over 180 radians. Now, just like, because radians is almost like the fraction form of this, take the fraction part of it, not the pi, just leave the pi there, but take the fraction part and see if it will reduce. And 120 over 180, if you need to do this on your calculator, 120 divided by 180, and then reduce the fraction, gives you 2 over 3. The reduced answer would be 2 pi over 3 radians. If you look at example B is starting you in radians, and it wants you to change it to degrees. So we are going to take our radian measure, and we are going to multiply by 180 degrees over pi radians. Well, one thing you'll notice is that the pi's cancel out, and then you will multiply straight across, and then go ahead and divide that out. Negative 180 divided by 12 gives you negative 15 degrees. Let's try a couple more. You can write some questions down here. I know there's not a you try problem here, but let's go ahead and do another one. Let's say we wanted to change 145 degrees to radians. You would multiply 145 by pi radians over 180 degrees. The degree symbol will cancel, and you end up with 145 pi radians over 180. And then check to see if 145 over 180 will reduce. And you get 29 over 36. So your final answer will be 29 pi over 36 radians. If you have any questions over this, make sure you add your questions here, and we will address those first on Friday. Okay. Now, we're not focusing too much on some of our special angles, but there are angles that we use more than others. Combinations of 30, 45, and 60, or 90 are angles that we use more often. This is a picture of the unit circle, and this is what we work off of quite a bit in trig and pre-calc. Notice that they give the degree measures on the inside, and on the outside are the radian measures. So this may be helpful for some of your homework problems, but just know that you have this here as a reference. Let's look over here. Let's do one more of each type. So let's say we wanted to change 135 degrees to radians. Since you're changing degrees to radians, you are going to multiply by pi radians over 180 degrees. Your degree symbols will cancel, and you are left with 135 pi over 180 radians. And then check to see if 135 over 180 will reduce. And it does, down to 3/4. And so you are left with 3 pi over 4 radians. Let's try example C. Example C, you are starting with negative 5 pi over 4 radians, and you want to multiply by 180 degrees over pi radians. The radian unit will cancel as well as the pi, and you will just multiply straight across. You'll do negative 5 times 180 divided by 4. And that will give you negative 225 degrees. Now, example D is slightly different. Notice it just says negative 6.28. If it doesn't have a degree mark, like that, we're just going to skip this one, but if you don't see the degree symbol, you assume it's in radians. If you are starting with a decimal, you may just multiply by this and give me a decimal answer back. So for this problem, what I would do is I would type in negative 6.28 times 180, and then I would divide by, and there's a pi symbol. You can put in 3.14. It's going to be very close. I'm just going to use the pi symbol. You should get about, we're just going to round it up, it's approximately negative 360 degrees. All right. And so if you start with decimal radians, you can just type the problem in as it is and give me a decimal answer back. Okay. Now, one place that we do need to use radians is if we're trying to find arc length or the area of a sector. Okay. When I used to teach trig, I would always relate these to pizza. Okay. Arc length is like the outer piece or the crust of the pizza. The area of a sector is the whole slice of pizza. Okay. So it says the arc length S and area A of a sector with a radius R and a central angle theta. Notice it says measured in radians, okay, are as follows. You can find an arc length by doing the radius times the angle in radians, and you can find the area by doing 1/2 times the radius squared times your angle measured in radians. All right, so let's look at this example down here. It says a softball field forms a sector with the dimensions shown. Find the length of the outside fence and the area of the field. Okay. Well, the outside fence, that is going to be our arc. So we are going to use our arc length formula. Okay. And let's just write down the formula and then plug in what we know. I don't know. Oops. That should be an S. There we go. Using that formula. I don't know my arc length. I can look at the picture and see that my radius of my circle is 200, and I have an angle of 90 degrees. 90 degrees is not in radians though, so if you go back, oops, one more, wrong page. If you go back to this picture, 90 degrees is the same thing as pi over 2 radians. That's what you'll want to use in the formula. It does have to be in radians, okay? So 90 degrees is equal to pi over 2 radians. And so I am going to want to multiply 200 times pi over 2, not by the 90 degrees. Well, that gives me 200 pi over 2, which is 100 pi. Go ahead and work that out, and that's approximately 314 feet. Okay. That would be the answer to the first question. Then it says find the area of the field. Well, I'm going to start with the area formula, which is 1/2 times your radius squared times your angle in radians. Okay, so I'm going to do 1/2 times my radius. Sorry, light went out. 200 squared times my angle, which again, I don't want to use the 90 degrees, I want to use the radian measure, times pi over 2. And just multiply straight across. On the top, you will end up with 1 times 200 squared, which is 40,000, times pi. And on the bottom, 2 times 2 gives you 4. That is the same as 10,000 pi, which is approximately 31,416 feet. And that would be square feet because area has square units. If you have any questions over this, please make sure you write down your questions, and these will be the first things we address on Friday. If you go to your Google Sheet, there is an assignment listed for today. You can do that on the same page as last night's assignment if you like, and we will turn both in tomorrow.